Another safety connection, fitting the work environment to the worker for safety success. I just wanted to remind you that this safety connection will be recorded just for your information. As with all of our safety connections, there's just a little bit of housekeeping at the beginning for those of you who have joined us before. These are recognizable, but for those of you that are new, welcome, obviously. So a couple tips before we get started here. So as with all safety connections, we certainly want to try to have some discussion, some back and forth. Hopefully, there is a number of polls that give you the option to respond to some questions that I'll talk about in a minute. But we try to utilize the chat as much as we can to have some of those discussions. So personal experiences, any experience with this content, questions you may have as we go through, please feel free to share in the chat. It's just a button you can see highlighted there, and obviously enter in your information in the chat would be great. If you need to go to full screen, you can adjust the content. Again, pressing the three buttons here, and that'll bring up a menu, and you can see everything in full screen. Polls will be launched by our people in the background, which is great. So they will be used throughout the session. So feel free to answer those questions as they come up as well. And you can see that they come up in the chat for you, so you can answer those questions as we go. So as I mentioned before, as with any other safety connection, we want to try to stay in touch as much as we can, connect virtually with our industry peers. So we do have quite a diverse group of companies joining us. So if we could, get experiences from everybody and learn from each other, we often present topics and, that we feel like, our customers need, but certainly hearing some feedback throughout the session or afterwards on these topics and the relevance to your workplace is needed. So that's part of the goals of this safety connection. We want to do those best practices as well. So there may be some situations, especially with ergonomics, that we need to learn from each other with best practices. So if we can do that throughout the session, then we've met the goals for the safety connection. So the first poll question, I just need to know what type of industry you're joining us from. So the poll is launched, you'll see there in the chat. I just want to use that to hopefully gear some of that conversation as we go forward. So just feel free to enter that in the poll here, and I'll give you a moment to do that. Okay, so we got some food, construction, manufacturing, food production, some grocery retail, perfect, aerosol manufacturing. Okay, so a bunch of different manufacturing, healthcare. Okay, perfect. Let's wait for a few more responses here. Cannabis manufacturing, okay. Okay, just give you a few more seconds here. Okay, perfect. All right, close the poll. That'd be great. Okay, so lots of manufacturing, different types of manufacturing as well, which certainly we'll focus on. So, okay, so for this session, I have to admit, I kind of struggled with the concept of this session. So I had a bunch of theory in this presentation, and sometimes that can be a little bit boring, but also difficult sometimes to translate that theory into practice. So thankfully, there's not a ton of theory. We're still going to talk about kind of the title of integrating ergonomics for safety performance. So we're still going to do that. Try to give you some practical examples of what that means, how that is impacting some other safety programs. So really, you joining me this morning, this is kind of a different approach to ergonomics, I think, anyways, in my opinion. I know that the the prevailing wisdom, I guess, with ergonomics is to use that to prevent MSDs, right, and musculoskeletal disorders, and that's of course what we want to do, particularly safety individuals, is that majority, or still around 30 to 40% of all injuries are musculoskeletal disorders or sprains and strains. And there's lots of great resources that have come out to try to prevent MSDs through assessments and programs, and utilizing websites like msdprevention.com and those types of things. But we're going to try to take a little bit of a different approach. So the hypothesis for this kind of approach is that ergonomics can be used to improve safety outcomes by incorporating design elements to make work and decision making easier and more intuitive. So that's my hypothesis for this, and hopefully I can convince you that we can do that. And as a consequence of doing that, putting in design standards or looking at safety from that perspective, the consequence hopefully is MSD prevention, right? That's a consequence of what we're doing. So hopefully as we go through this presentation, I can give you some examples of how to do that, or at least to show that perhaps you're doing that type of stuff already, right? So that's kind of the barrier sometimes with ergonomics in general, is that we don't think that we don't have a program or nothing official. It doesn't mean that you're not necessarily doing anything. So can we do this to take this kind of approach to show that yes, we are doing it, what counts towards MSD prevention, or implementing ergonomics to help with different safety outcomes. So hopefully we can kind of talk through that together as we kind of go through this. So I was just trying to think about, like, how could I take this and kind of connect it to safety, and it got me thinking about, like, why is safety so challenging? Like why is it such a challenge for us to, identify hazards, or change with how work is changing, and it came down to a couple things, and if you can put it in the chat if you want to contribute to what makes it challenging, and there's lots of things about management support and those types of things that we've heard from lots of companies before. But what makes it so challenging is, you know, obviously there's lots of diverse hazards, right? Depending on, what type of industry that you're in, whether you're in, if I have an example of cannabis manufacturing, for example. Been in some places where, maybe doing some lateral reduction, for example, where I've been in some cannabis facilities where you're kind of sitting on a mechanic stool and you have scissors and you're cutting off some of the leaves on some plants. And that was a while back. Maybe that process has changed a little bit, but sometimes the scissors that maybe you're using get all gummed up from the plants, and then it's a lot more difficult to open and close, right? So there's just these, depending what industry, and there's just all these different diverse hazards, right? Food manufacturing, I've seen floors slippery because of ingredients or something that are on the floor, right? So just oils and stuff like that, right? So definitely a challenge that, depending on what we're manufacturing or how those manufacturing processes change, that it just seems like hazards, just happen, right? And we need to try to figure that out on a daily basis. It seems like we're always, doing our best to mitigate those hazards, but they just seem to be popping up. So definitely a diverse set of hazards are the issue that we see. Obviously trying to comply, right? Understanding what that means, what we need to do to comply to different hazards that we see. Just from an ergonomics standpoint, you look at something like Section 45A that talks about handling material, pushing, pulling things in a safe manner. We push and pull things all the time and lift things all the time. Well, how do I know that somebody's lifting something? How do I know that that's safe for them to do? So, and how do I know if I'm complying to that? So that's certainly an issue as well. It's just keeping up to date with compliance, predicting and preventing adverse events. So, like, how do we predict those, right? Like, do we have predictive models to know what happens when an adverse, if we had that, then nobody would get hurt, right? So really, what do we need to do to prevent those events from happening? Because we know those events occur, right? So how can we put controls in place to, even if it's preventing the severity of those events, right? What can we do to try to predict and prevent those? And that's ultimately what we're trying to do as health and safety people is, we look at proactive events like, how can we predict, those events under certain conditions and try to prevent them from impacting the people that we're charged with keeping safe at work. But the other two, last two that I see, is the unpredictability of work. Like for example, at a food distribution warehouse, they may have a promotion on a particular product. So that promotion means that there's going to be a greater run on those products, and therefore there's going to be an increased amount in order picking, for example. And is that enough to, push people over the top for developing an MSD, for example, right? So although we've put the things in place and did lifting training and made sure the heights are okay and all that kind of stuff, that even those types of things can change how we do work, and how work is supposed to be done. And those are the kind of monkey wrenches that are thrown in that then, cause these kind of diverse hazards or these adverse events from occurring because work has changed maybe from one day to the next, right? Based on things like promotions and special products or whatever it is. So certainly that unpredictability is a challenge for us as well. And of course, the kind of the key to all of this is the human, right? The human is the center of this whole process, right? And that may sound like an understatement because that's who we're protecting, but really what makes me, good at doing things and what makes me poor at doing things, right? What decisions am I making personally that are leading to these adverse events, right? Or is the work asking me to do something that's putting me at risk, right? Like lifting something heavy, for example. So that's really a challenging thing is really understanding what really our strengths are as humans and what our limitations are, what we can and can't do, and how is that related to health and safety and reducing those risks, right? And so really what we want to try to do is we really want to bridge that gap between work and and really what our capabilities are, obviously, right? So again, we know that 85 decibels over an 8-hour period or over a typical workday and more than that, that is against our capabilities of handling that much noise, right? And then there's damage, right? So that's really, we look at legislation, it's legislated that way, so it doesn't exceed what our capabilities are, right? So we can kind of predict those types of things, whereas other things are very difficult, where we lift, 20 kilos and it hurts somebody, it doesn't hurt somebody else. So really understanding what those capabilities are and understanding what that unpredictability is really what we want to try to bring together as best we can, right? And we think that ergonomics can do that to a degree, right? We feel like, based on different design standards and kind of changing how we think about ergonomics, will help contribute to that anyways, right? I shouldn't say it's the whole thing, but contribute to that as well. So that's really what we want. We're kind of looking at how can we help make EHS a little bit less challenging by figuring out the predictability of work, understanding really as humans why we make decisions, and then trying to bridge that gap to give you a little bit more ammunition or a different way of approaching what you're doing to kind of mitigate some of those risks. So hopefully there's some examples in here that you will find appropriate. If there isn't, of course, we can have discussions afterwards, or you can throw it in the chat and we can have those discussions as well. So the next question, I just want you to, you don't have to write anything, just could be one word sentence or a couple words, whatever there, but what do these industries have in common? With space and military, nuclear, oil and gas, airlines, and medical, from a safety perspective, right? From a safety perspective. So what do these industries have in common? So I'll give you a few minutes to answer this question as well. And if you want to think about, yeah, high stress, I was just going to say, like, high risk, high stress, complex for sure. Yeah, absolutely. Complexity, yeah, toxic, yeah. Different hazards for sure. Manual work, yeah, absolutely. It seems like hazards and high risk are really popping out for sure. Expertise, yep, yeah. And what happens, in these industries if something goes south from a safety perspective? So you're in space, military, nuclear, airlines, medical, compliance levels, yep. Yeah, just give you a few more seconds here. Yeah, okay, no, that's awesome. Yeah. If you want to close the poll, that's great. Yeah. So it seems like high risk and hazards and complexity. I see some themes there for sure that that are prevalent. Yeah, in these industries, I mean, they're pretty dangerous, right? I mean, if things aren't followed, then that's where, accidents occur. And unfortunately, we're seeing that right now in airlines, for example, with it's an airline where a panel blew out in mid-flight, right? Worst nightmare. I think there's another incident, or at least I feel like I saw that on the news either today or yesterday about finding other um, conditions with a particular airplane that might create some issues. So yeah, like in these industries, they're so dangerous that if something goes wrong, then there's severe consequences, right? And so when you think about the protocols they have in place or the systems they have in place, I'm not suggesting things are perfect because accidents do occur, and there's lots of evidence that accidents do occur or mistakes are made in these industries. But they're so the safety systems and the way in which they do their work, the way in which the work is designed with safety in mind, right? Um, Obviously, military is a perfect example of that. Medical, the the procedures they go through, for surgeries, for example, over and over again, is designed to ensure that the right thing is being done at the time, right? Even though they go through those processes every single time. They know that you need to make sure that you're operating on the right leg or something, right? So because mistakes have been made in the past. So it's just more of really complex industries where all stakeholders need to be involved to ensure that people are safe, not just the people doing the work, but also the customers that they serve. So that's a pretty high standard from that perspective, right? And I get that we're on a different scale here potentially based on the type of work that we do, but it kind of I just want you to keep those industries in mind when we kind of go through this particular mindset as we go through to try to incorporate really ergonomics into the way in which we do work. So just keep those in mind as we kind of go through. So the first thing I need to do is the first bullet point here has to do with is the definition of ergonomics, right? And really quite simply is fitting the work to the worker, right? To the work environment to the worker is kind of a simple definition of really what ergonomics is. But what I find important with this particular definition in what we're trying to accomplish today is really overall system performance. And really what that means is that ergonomics really, when you look at this definition in particular, is that it's really understanding our interactions between, us as humans and in all of the elements of a system. And I'm going to talk a little bit about really what a system is and the influence that you're having on that system. So the system really has to do with, all of the things that I need do my job, right? So really sitting at my desk here, I got a chair and desk and monitor and laptop and software and coffee and all that kind of stuff, right? To really look at how all of those things are performing in order for me to do work, right? And the influence of all of those things needs to optimize my human well-being, and in turn is going to influence how well that system performs, right? So again, taking into consideration my workstation, if something out of all of those things aren't performing, is that going to affect my ability to perform the work, right? Something goes wrong with the software or my technology, or if I have substandard working conditions, working at a kitchen table, for example, all of those types of things are going to impair my ability to perform the job, right? And of course, what we deal with as safety individuals is how that performance potentially, or how we're doing that work is potentially going to expose me to a hazard, right? So of course, substandard conditions sitting at my kitchen table, which I'm not doing, by the way, but sitting at a kitchen table, for example, is potentially going to lead to an increased amount of exposure to MSD hazards, which potentially could result in an injury, right? But what the focus of this presentation, as I did with my hypothesis earlier, is looking at how well that system is performing, right? So again, our focus is squarely on the safety part, right? But if we can show how that whole system is performing, then from a safety perspective, that I should, in theory, be more productive, right? I should be, in theory, more productive, right? So if I have great, um, great um, software that allows me to do my job, is responsive, I'm comfortable, I can sit and stand or whatever I can do, that all of those types of things should allow me to perform safely. And if I have that ability, then perhaps it helps me to reduce my exposure to MSD hazards, right? Because I've taken into consideration tools and equipment and products and all of those types of things to allow me to perform a lot better. Okay. Whoops, I'm going to go back here because I missed that last one. So what I want you to do is I want you to think about ergonomics for safety, or for safety for that matter, in the context of that human performance. So it's not performance in terms of, which I just alluded to performance in terms of, productivity and getting more work done. From here on out, I want you to think about my ability to perform work safely, right? So if I don't have the right equipment or the right setup, or work isn't designed in a way that I'm not able to see or to notice things in my blind spot or something like that, that those types of things are going to impair my ability to perform the work safely, which then I think is going to impact safety programs. So just to give you a quick example, which again I may talk about a little bit later, but I feel like I should put in a little bit of context here. So let's just say, from an MSD perspective, from an MSD, let's say I have some neck discomfort, right? Because I'm always looking backwards in my forklift, for example, is that if I can't turn my neck, or it's uncomfortable to do that at the end of the day, or I'm fatigued, for example, because I'm doing that all the time, then if I need to turn 30 degrees or 40 degrees, but I'm only able to turn 30 degrees or 20 degrees because of my neck or the discomfort in my back from twisting all the time, what is that going to do to my blind spot when I'm driving a forklift, right? It's going to increase that blind spot, right, out to the side. And then maybe I don't notice people where if I didn't have an MSD, I'd be able to see that person, right? Be able to turn. So again, having some restrictions like that could, ultimately result in contributing to a struck by, for example, right? So really, for me to perform, to turn my neck into the right angle to see people, is really what we're talking about. So can I perform the work in a safe manner? Is really what we are looking at as well. It's really what's important to us, right? Is making sure people have the tools the process, the equipment, whatever it is, to be able to perform the work in the safe manner. A lot of that has to do with what's expected of me, really what my needs are as the human in order to do that work. And we're going to talk about that right now. So oftentimes we see a conflict, right? We see a conflict between really what my needs are as a human and what my work needs in order for me to do work, right? So of course, as a human, I got to have the skills and knowledge, the physical and mental energy, motivation, resources, teamwork, a safe work environment. I need those things in order to perform work, right? So those are kind of big, and there's if you type that in, there's a ton more, but I just kind of picked a few. So there's lots of things I need as humans in order to do work, right? And there's money and all that kind of stuff as well. But these are the ones that I feel like were important for us to talk about. But then, of course, there's work needs, right? We obviously need to have you a certain physical ability or even a cognitive ability to do the work. We want you to have a quality focus. There's certain productive or production requirements that we need to do, or production targets we need to do in order to, keep the lights on and all that kind of stuff. So really there's kind of these two competing priorities, and companies are really trying to kind of bring those together, right? Can I match the work needs with the human needs, and we should be good, right? And what we do as safety professionals is we like, hold on, okay, there's work needs and there's human needs, but then what we're trying to do is we're trying to shove the safety wheel in between, right? So, work is outputting, certain things, which results in hazards potentially. And, humans could be doing certain things which are resulting in hazards, right? So, we may control a whole bunch of things, but, provide safe lifting training, for example, and the human decides not to lift safely, and then we have a whole other problems, right? So really what we try to do as safety professionals, we're like, oh, hold on, let's, you know, if these two things are not meshing, um, you know, mixed in with the environment, then that's where we start to get some of these hazards, right? Start to occur. So that's really the challenge too, is trying to find this balance. So hopefully we can try to do that for success, right? Is marry work needs with human needs, and then identify our hazards and satisfy all that kind of stuff, right? So I think the best way to proceed then moving forward is really understanding really what our human strengths and limitations are, right? So there are things that we can and can't do, right? And we're talking about humans as a whole, right? Not individuals that you have at your workplace, but humans as a whole. And what's important with understanding really what our strengths and limitations are is helping to influence how that system works so that we can take advantage of the strengths, limit the limitations, and then or reduce the limitations, and then hopefully that leads to better performance of the overall system. So and you're thinking to yourself, well, like what does this have to do with MSD prevention or with safety, right? And a lot of times with safety, there are decisions that we make a lot of times from the human that keeps us safe, right? Now, I'm not saying there's hazards all over the place and we're dodging and ducking, things that are all over the place, but there are certain things, if based on the training that I have, or, the ability to follow, a painted line on the floor, right? There's no barrier there for me to cross. That's showing that I'm able to follow instruction, or I have some adaptability to my environment so that I can make proper decisions, right? So that I don't put myself at risk, right? I have the ability to do teamwork or communicate issues or solve problems that, a lot of times those types of things will help me to prevent accidents, right? Because I'm problem solving instead of deciding to go, into something, I'm trying to solve the problem, right? And oftentimes as safety people, we provide them with the tools to do that, right? Well, you need to go in and fix a machine. Well, we're solving one problem for you by providing you with a lockout tagout program, for example, and providing you training, right? So when you're thinking about solving a problem, you're taking the appropriate steps to do that. And humans have that ability to be able to do that, right? But at the same time, they have the ability to make the opposite decision, which is I'm just going to go in and fix that because it looks pretty easy, right? Without without understanding the risks, and we know what happens when they do that, right? That's why we often have to do what we need to do because we're trying to guard against the times in which humans make those decisions, right? And that's one of the limitations that we have. Sometimes we just we convince ourselves that I'll be okay when I do certain things, and we know that that accidents occur, and that's really what we're trying to protect against, right? But in the context of health and safety, we obviously have physical limitations, right? That's really what we do as ergonomists is we try to understand really what those physical limitations are, and hopefully design work around providing some strategies to prevent injury, right? So I'm sure people look at 23 kilograms as a safe lift, which is under ideal conditions, but we try to look at things. Well, you're limited in lifting if you have to reach out far away and bend over to pick up that 23 kilograms, so we can kind of tell you we can try to scale back that weight based on what those physical limitations might be under those new conditions, right? So there's certain things we can't do physically that we need to try to um, account for, and you'll see hopefully in some of the examples of how that plays into different safety perspectives. So I know I'm talking about lifting, but there are different safety things that we'll talk about in a minute that will really talk to that hopefully in a little bit more detail. We certainly have cognitive limitations, perceptual limitations. We fatigue, we have stress, right? So all of these types of things need to be taken into consideration to try to make sure that whole system or having a good understanding, right, will allow us to have a good idea of how to design work safely. And there's lots of and I guess ergonomics in general is a little bit gray because like I said, with lifting, for example, is the easiest example that, we know that lifting something really heavy can cause back injury. But when that weight is not that heavy, but not that light either, like, how do I know between different people whether or not somebody will get hurt or not, right? At least for like noise, for example, I have a number I could say, yes, 85, I'm good. Let's reduce that. So there's lots of different things like that with safety makes things a little bit easier. It makes it a little bit more difficult with ergonomics. Um, does anybody have any? I know that your camera's off and that type of stuff is all that stuff is off in uh, on here. But if you want to put in the chat, if you have any questions, then feel free to put it in the questions as well. Sorry about that. I got a meeting I'm not a part of that all these notifications are popping up, so I apologize for that. We'll hopefully try to mute that if we get a chance. So okay, what I want to talk about now is really what a work system is, a complex adaptive system, and really what that is really just when you think about work, and the photograph on the left is really what AI's interpretation of what work is, to be honest with you. It's just a whole bunch of things all twisted around. I said kind of make a spaghetti diagram of work, and that's really what I came up with. So it really is just a dynamic network of interactions where individuals and collective behaviors adapt and self-organize in response to change. So really what that means is that at any given time, we're given a task or there's a set of requirements we need to do in order to do our work. And that's the strength of a human. We're able to adapt and change our behavior and organize to really figure out how we need to get the work done, right? So work system just it changes all the time. And this is when you talk about, cannabis manufacturing or food manufacturing or healthcare, or any uh, industry that you're in, that's really what it is. It's an interconnected network that's always changing of activities and work and decisions that are being made that will potentially impact my ability to do work. And we're not going to get into, a lot of detail about really what this work system is, because, you know, you are you and I and other safety professionals are really one portion of this kind of dynamic network, right? And it almost seems like a lot of times, we're trying to, how can we get the attention of all of these individuals, all of these stakeholders to be able to say, look, when you're making these decisions in response to whatever changes, can you please incorporate, these types of things to, run it through a safety filter, for example, so that when you're making a change to a workplace that it considers, X, Y, and Z, right? So, that's really the challenge of safety, is that it's kind of off to the side, and how can we integrate it into this work system so when those decisions are being made that they incorporate um, they incorporate the principles of safety into how those decisions are being made. And, going back a couple of slides to the poll I talked about with some of those different industries, it seems like it is in there to a degree. And there's an inherent danger in the work that those industries are doing, but and that inherent danger is understood, I think, in all stakeholders, right? um, and that's unfortunately based on precedents, right? What has happened in the past in a lot of those industries, and that doesn't mean that they're still not dangerous to a degree. We can certainly do that, um, but they've looked at all the risk and tried to reduce the risk and the severity as much as they can based on how they do their work, right? How they carry out different exercises in the battlefield, right, to keep people safe. Again, understanding there's an inherent danger, but this really work system is working together to know that at the end of the day, the task we're requiring those individuals to do, or the effect that it may have on our customers, can be catastrophic. So there's an inherent understanding that the work is dangerous. So, we talk about management support and all that kind of stuff. I mean, again, that individual or those individuals or your board or senior leadership team or whatever, understanding that work can be inherently dangerous depending on what you're doing without any controls in place. So how do we integrate that safety concept into a work system as a key driver to how the work is being done at the end of the day? So I feel like that's the ultimate goal for us as safety professionals, right? Is to be at that point, right? And using some of those other industries as kind of a comparable for you is suggested as well. Um, yeah, so why do we want to focus on systems? So individually, and you see kind of this graphic up here. It talks about safety 1, safety 2, and safety 3, and systems engineering, safety engineering, and all that kind of stuff. And we won't certainly go into it in too much detail because there's lots to talk about with all these types of things. If you haven't heard about it, you can Google safety 2. There's a paper on that. Safety 3 is another paper that's light reading. It's only 110 pages of a engineer at MIT that talks about safety 2 and some of the flaws in that paper. So if you have a bit of time on your hands, you can certainly look at those things. I can certainly provide you the links to those. Actually, maybe I'll do that post safety connection. I can provide you the link to those two things. But so why do we want to focus on systems? Well, I think that we do that already to a degree. Like we kind of pick different things based on the hazards that we identified through the methods that we utilize, whether it's workplace inspections or looking at leading and lagging indicators, all that kind of stuff. We try to find risk. We have our lagging indicators, injury rates, even injury rates in our own um, sectors, for example, and then looking at leading indicators of what those types of things are in our workplace that potentially could lead to accidents that haven't occurred. And that's kind of our previous concept about predicting behavior, predicting when accidents may occur based on different portions of the system, right? Whether the humans are doing that or whether it's equipment such as dented racking or whatever it is, right? So we're doing all those things to do it. So really you are focused on the system or portions of the system based on the types of things that you're looking for, right? So in safety tools and equipment and environment, like how all those things are set up, that's in the individual risks that are contained in there that would lead to or potentially lead to injury, right? Or hazards or have led to injury. So generally when it comes to the attitude really of the human factor, and that's really that kind of change in mindset is looking at how we approach that from a human perspective, right? And I'm not saying we do that necessarily, but we focus on a machine, we try to guard that machine because we know we need to do that for compliance and we come up with all that kind of stuff. But if a human then starts to work with that machine and they get injured, is are they the kind of liability there, right? Because they did something, right? Did they circumvent the guard or do something that led to that particular injury? So really, humans are predominantly seen as that liability or hazard, right? And a lot of times we try to engineer that out too, right? So why should I rely on the human making a bad decision when I can put something in place that's pre-programmed so that the human, that liability or hazard's kind of removed, right? So, but then we proceed to safety two, which is humans are seen as a resource is necessary for system flexibility and resilience. So what that means is that we're starting to build on the strengths of what people can do, right? So, you know, like I said, decisions, I have the ability to make decisions or to, my behaviors can change based on how the work has changed and have that reliability and that adaptability to allow that system to be flexible to change with changing work demands, right? You put a crane in, to do a certain task, right? Well, that, if something changes, like I said earlier, with, a special goes on, at a store, so you need to pull certain things, that crane won't have the ability to go straight, right? They can only go back and forth, for example, right? So that's where the humans' adaptability and flexibility needs to come in there to ensure that that whole system continues to work, right? So we have some flexibility and we do have some resilience there as well, safety too. When you look at system safety engineering, humans are expected to prevent or respond to hazards and be flexible and resourceful when they occur, right? So there is an expectation that, when those things occur, how can I avoid it? Um, how can I understand where those are coming from and make changes to how that system is operating so that I'm not putting myself, at risk, right? That's really safety system engineering. And then we get into safety three, which is the system must be designed to allow humans to be flexible and resilient and to handle unexpected events. So really what it's saying, and if you read this paper, they talk about root cause analysis and how, you know, the root cause is really not a root cause. It's based on how the system is designed that then put me at risk, right? So there's lots of things in there that, you may feel like goes against what we're used to as safety professionals. There's some things in there that certainly are understandable and how we can kind of allow humans to be flexible and resilient to handle some of these unexpected events. Because we know things will inevitably happen, right? As much as we try to eliminate risk and reduce um, severity based on the controls we have in place. What happens when these unexpected events occur? We typically rely on the human to be able to be flexible and resilient to be able to respond to some of those events. And so again, I don't want to get into a big thing about the merits of safety 1, 2, and 3, but I'll send you that information so you have it, and maybe pull some tidbits out of there. But essentially, it's talking about, you know, taking that kind of human-centered approach to help them perform safety a little bit easier. So really getting back to really what we're supposed to be doing here is looking at fitting the work environment to the worker for safety success. And really, what does that mean? Well, really what we're trying ultimately to do is find a balance between the needs of the worker needs, and the need to complete the work safely, right? So if as a worker I need to be able to hear my, you know, my partner, but the work requires me to wear hearing protection so that I, you know, am able to protect my ears, then, you know, how do I find the balance between those two things, right? Is it, you know, is it the type of hearing protection? Is it the, you know, hearing protection that allows me to hear human voice but blocks out everything else, which again are expensive? But it's really trying to find those balances, right? And when we don't find a balance, that's where that conflict happens, right? So as a worker, like there are certain things I need in order to do my job, right? And if I don't do those, if I can't do that, then is that where I circumvent, right? Especially if there's incentive for me to do more, right? If there's incentive for me to do more, and safety puts up a barrier because, you know, if I go over that barrier, then I'm going to get injured. Well, you know, that's where kind of that limitation is. Maybe I make, you know, you know, I say the risk is kind of worth it, so then I do it because I can make more money, for example. So that's really the key for this, is trying to find that balance between all of that. Okay. So let's get into, you know, how the lack of ergonomics can contribute to accidents. So so I have a couple of slides here just to look at different safety things that are topics that we potentially we potentially deal with, and, you know, how kind of the lack of ergonomics can contribute to that. So falls from heights, poor ergonomics in the design of elevated platforms or working surfaces can contribute to imbalance, leading to an increased risk of falls. So, you know, I'm sure there's standards for railing heights. Well, that's based on anthropometrics, which are what is the average, you know, height for an individual, right? So is that where that railing, you know, the railing needs to be higher than the hips for the majority of the population, right? So we don't fall over, right? Is the floor, you know, slippery, so I'm going to slip on something, right? So, you know, am I required to lift something that is going to, again, cause me to be unbalanced, fatigue, and fall, right? So again, it's more of, you know, I am manual materials handling, but it's leading to a fall because of the fact you know, lifting over here, it's causing my shoulder to fatigue, and then I drop it and I fall over. Electrical hazards, awkward postures, or uncomfortable working positions due to poor ergonomics can distract workers and increase the likelihood of mistakes, contributing to electrical hazards. So again, working overhead causes fatigue. Can I, you know, is that leading to my decision? I just got to do this quick because I'm getting tired, it's sore, and then that's where the injury comes in, right? So even awkward postures are putting me in a position that's going to potentially push me to make a decision that I might not otherwise make because I'm in a fatigued position. Heavy equipment and machinery, poorly designed control panels or workstations can lead to awkward body positions, increasing the risk of errors when operating heavy machinery. Chemical exposure, awkward postures during tasks like handling chemicals can result in spills or improper handling, increasing the risk of exposure. So again, you take a bucket of chemicals and you're carrying that, you know, the chemicals are sloshing around, it's increasing more force on gripping, you know, arm discomfort, those types of things. Is that going to lead me to dropping it more and then it opening and being response to chemicals? So again, we're talking in some of these things, especially with the awkward postures, that there is physical limitations here that are leading to a potential issue with some of these different hazards, right? So what's relevant with a lot of these things is that the way the work is designed is asking me to make decisions or to think about what I need to do, but also physically do something, right? So it's allowing me to physically do something. So while I may have fallen from a height, is it because I was fatigued or physically incapable of, lifting that item as I was doing something, right? So really the poor ergonomics which is really not a term, but the way in which the work was designed is directly related to my ability to do that work, which then led to a fall, okay? Or a dropped chemical or something like that. We have a confined space, right? Inadequate workspace design and confined space can force workers into awkward postures, increasing the risk of fatigue and discomfort. Slips, trips, and falls. Poorly designed work areas when cluttered or uneven surfaces can increase the risk of slips, trips, and falls. Well, okay, well we know about housekeeping and all that kind of stuff, but what if you're carrying a box and you can't see the floor, right? And you're walking and you trip on a pallet or something, right? Is that because of the positioning of the pallet? Is that because I couldn't see, right? Considering that human factor, right? I couldn't see where I was going, or I was rushing because, we had a special on it. We needed to get products out, right? So really, how can we rely on the human's resilience and ability to regulate how they work to overcome some of those issues, right? So it's looking at slips, trips, and falls and the conditions of work that are potentially resulting in those types of things. And we get that there's in some cases there's a reduction in coefficient of friction, which is going to lead to more slips, right? For working outside now, or oil from baking ingredients on the floor, those types of things. But certainly putting something in our face as we're trying to handle those types of things may prevent us from seeing those things and resulting in discomfort. Sharp tools and equipment, uncomfortable workstations, or inadequate tool design can lead to improper handling, increasing the risk of cuts or puncture injuries, right? Again, I have something that I need to apply a lot of force to poke, right? That if I'm trying to go really hard and I slip, I could injure myself. Maybe the tool I was using wasn't sharpened properly, that resulted in less force to puncture something or to cut open a bag or whatever it is, right? So I know in a lot of meat cutting, I didn't see any meat cutting, but there's different ways of sharpening knives depending on what type of meat you're using that makes it easier to cut, right? Again, if you're having to cut in, applying more force, I'm more fatigued, does that stop me from, if I poke in, if I'm fatigued, does that, prompt me to go forward a little bit more, which results in me, hitting something or cutting myself. So looking at those types of things and how I'm working, how things are positioned, right? If I'm fatigued and I need to cut things open up here, is that, putting me more at risk for injuring myself than say if I was in a better posture, right? So we talk about neutral postures, sitting, well, in this case, for standing, for example, we're standing, everything's comfortable, arms at 90 degrees, for example, that's comfortable doing work in there than doing work up here, which could lead to some of these things that we're talking about. Fire and combustible materials, poor design of workstations for welding or cutting can contribute to errors, increase the risk of fires, right? So how I'm doing those activities could result in that because I'm fatiguing as I'm doing that work. So proper work design or placement of materials as you're doing work could contribute to the reduction in errors, right? Because I'm able to make the right decisions because I'm not fatigued, or I don't, I need to get the work done, but my shoulder's sore and or fatigued, and that's where those issues come from, right? So you can see that if I'm working up here, but I change it to down here, is that reducing my errors for welding? But as a consequence, as I mentioned before, that we're reducing MSDs as well because I'm not up here doing the work, right? And I get that, it's not that simple, right? Let's change this from this, right? But if we know the limitations are doing this for an extended period of time, how do we change the way in work is designed so that I'm not having to do this constantly, which is then starting to open me up to some of these other hazards as we talked about. A couple of other ones: lack of ergonomics can contribute to accidents, mechanical failures, discomfort, or awkward postures due to poor ergonomics can contribute to errors when operating machinery, leading to mechanical failures. Poor ergonomics, again, I hate that term, but just discomfort due to poor design can distract workers, increasing the risk of being struck by moving objects. Hand-arm vibration, poorly designed tools without proper vibration dampening features can actually exacerbate the impact of hand-arm vibration. For example, there's also whole body vibration as well. I went to a workshop a few weeks ago by CROSH, Center for Research in Occupational Safety and Health, if you're familiar with them. And they did some studies on, anti-vibration gloves, and some of them actually increased the vibration, which I found was interesting. So as far as struck by goes, so I'm gonna do this just based on time, because we just have about a bunch of slides left, so I want to make sure I get through them. But if you want to respond in the chat, you can. There's no polls for this one or anything, but I would try to make this a little bit interactive, so you can throw it in the chat if you want to as well. So this is an actual incident that occurred. The worker operating a forklift attempted to place two by 16-foot boards into a pile when the second worker walked towards the back of the forklift. The forklift operator moved the forklift forward, striking the other worker, who sustained critical injuries. So based on this instance, what was the cause of this instance? And I should say that this happened in a yard outside, right? So not inside, but outside. So clearly in this case, the forklift operator didn't see that individual, right? And the way the process worked is they had two people to do this, right? Because they needed to ensure that these things were transported into a pile outside safely. So they had two individuals kind of operate this, right? So clearly they didn't see and backed in, right? So what would be some of the changes that would potentially, this may be categorized as a struck by, right? So what types of things could we do to fix this? Well, certainly improved visibility, right? So and I've been in places where forklifts are lit up like a Christmas tree, right? You got red lights, you got blue lights on there, you have kind of the halo around the forklift, essentially, right? A certain distance away, right? And there's a reason why it's, I think, 3 feet away. Don't quote me on that, but I feel like it's 3 feet away. Is that you're not in any 3 meters? Sorry, 3 meters. Yeah, thank you for that. So there's a reason why you're 3 meters away, is that then you can get the operator to actually see where you are, right? So again, think about like a truck, for example, right? If you're right in front of an 18-wheel truck, the person sitting high up in the cab can't see you because of obviously the depth of the engine compartment in front, right? But you may need to be 10 feet away or 10 meters away for that person to see you, based on how the visibility works, right? So certainly improved visibility would be important, right? Clear sight lines, unobstructed views that contribute to that work, right? Certainly effective communication, right? Clear signage, audible warnings, visual signals, proximity detectors for sure. Blue lights are great. Forklift and pedestrian program. Like all of those things are ways of which you're trying to control the humans in that system, right? But you're also, in some of the examples that you're mentioning in the chat, is you're looking at some of those other elements in the system to try to contribute to that system safety, right? Whether it is, the blue lights or the hazard zones on forklifts, proximity detectors that shut down the operation of those forklifts, whether you put programs in place like pedestrian safety programs, like these are all kind of levels of controls of organizing that system or changing that system to see how effective it's going to have, right? But where things change is, pedestrian programs and all that kind of stuff, right? But again, like I said, work and systems and all that kind of stuff is dynamic. So, again, what happens if there's a rush order or I need to get something out quickly? I mean, how does that change that particular program, right? So that one time I decide to not follow the path and cut across because I needed to get something in place that's going to take 2 seconds, and then that's where the incident occurs, right? So it's those eventualities that occur that how can we design the system in a way to try to account for those is important, right? And with some buildings or newer buildings I've seen with pedestrian programs is a lot of those pathways are actually are have barriers up, right, as opposed to just a painted line in the floor, right? So a way of kind of optimizing that workflow, right? Of streamlining that and organizing, congestion and reducing the chance of workers colliding with other workers because that variable is removed from the situation, right? So again, yeah, safety vests needs to be worn for visibility. I've been in places where some safety vests actually blend into the background, right? So safety vests are one thing, high vis safety vests are one thing, but having that contrast between the individual and the background is important, right? So I mean, there's not many places that blend in with bright orange and yellow, but a recycling facility does, right? So in some cases, so ensuring that you're reducing the chance based on optimizing that workflow, right? So they need to take that out to the pile outside. Like, what does that workflow look like, right? If that's something that needs to be done on a continuous basis. If not, then if things are done like that, as a response to customer demand or whatever it is, then what types of controls can we have over that to try to reduce some of that likelihood, right? Yeah, thanks for that, Natalie, for that case study. That's perfect. So, appropriate equipment design. This comes to with again, not to say that this was part of this incident, but if you had a forklift that you had somebody in a forklift that it was, the controls were, let's say you had somebody tall on a forklift, for example, and they went to depressing the accelerator and they saw somebody coming and they needed to hit the brake quickly, right? If they needed to shove their knee in their chest to then hit the brake, then that's going to alter the reaction time a little bit, which may be enough to hit somebody, right? So you can see even fit of the forklift and having adjustability as much as you can to allow that person to perform the activities of driving that forklift safely, right? So like having all of the stuff that you put in the chat is great. It's required. But if as the human in the forklift, do I have everything I need in the forklift in order to operate that forklift safely, right? And I mean that in the context of, using levers, steering wheel, seat that helps absorb some of the vibration, speed limiting. Somebody mentioned about proximity detectors that stop the forklift. Make sure it's fitting me as much as we can, right? So that I'm not delaying, putting me to try to figure out how to hit the brake quickly. And again, that's the difference between being struck by or not. Yeah, definitely communication, situational awareness, and we know based on work. I mean, there's times you get uber focused on what you're doing, and you're not sure what else is happening around you, right? We experience that sometimes when we work, right? We kind of get in the zone, right? And in doing so, some of that stuff almost goes out the window, right? So, you know, even though we'd like to have situational awareness all the time and be present, right? Sometimes we're not based on work, right? So is it training to make sure, like Jamie, like you said, about communicating all the time and having that situational awareness and understanding that, but harken back to the way the system is designed. and why are people there? Why is this there? Why is that there? That I need to try to make decisions, and that's where injury occurs. So it's important looking at that kind of stuff and task analysis and all those types of things. And there's lots of different things about this. I do need to move on, but minimize distractions, clear pathways and work zones, training and awareness, as you mentioned. So there's lots of different things here that I think it's safety, but it's performance, right? It's me having the ability to perform the work in a safe manner, right? I'm not sure who is at fault here, whether it's the forklift operator or the helper, but it's the way in which the work was designed and the task was designed that put somebody at risk here. Okay. So I want to give you another example of PPE. I know I went through kind of a lack of, but I want to give you a couple of examples. And what I'll do is just kind of looking at what I need to get to. But I'll send you, if you don't know this already, CSA put out a report last year about the lack of PPE designed specifically for women. I heard a lot of people at WSPS who've had to modify their own PPE to fit. So, just think about how even the extra PPE, in the pandemic may have led to, increased trips and falls, right? Because you had glasses and a mask and reduced some downward visibility, fogged up and your safety glasses, whatever, and resulted in additional risks, right? But I'll make sure I include that CSA study if you haven't seen it already that talked about the physical and physiological differences. I mean there are physical and physiological differences between the sexes and PPE that currently exists. We just can't scale it down, right? Just order a small instead of a medium or whatever it is, right? So um, all of those things can impact how we perform, right? Things don't fit, again, from an MST perspective, maybe the gloves are too big or whatever, then that's going to increase my grip force and create issues. But again, if the glove doesn't fit and I need more grip force, does that increase fatigue as I'm holding something that's dangerous and I drop it because I can't hold it anymore, and that's where chemicals spill, right? Um, so that's kind of of how this presentation is looking at that, right? That yes, there's grip strength from holding that bucket, but is it the lack of fit that's creating more of an effort? I'm not getting an MSD, but it's causing me to drop it, and then that's when there's a spill, right? So that's kind of um, what we're doing. And yeah, that's a great point about PPE, right? And our workforce is changed, right? I mean, our workforce has changed from what it was back in the day, designed for an average male in North America, right? So even the work has changed, requirements of design of work has changed, and it's hard to try to scale things down for different populations that it's going to start to lead to these types of issues. Okay. So how can ergonomics help with these types of things? Well, if you look from falls from heights, for example, is that you can design those elevated platforms with non-slip surfaces, guardrails that are at the appropriate height. You can have anti-fatigue matting in those if it's appropriate. Ensure your fall protection fits properly, right? So having the appropriate fall protection, and you kind of practice ergonomics already because you may have all this PPE that you're trying to find that options to fit, right? So hearing protection that fits different types of ears. I mean, that's design anthrometrics, ergonomics. If you've heard of anthrometrics before, it's just the measure of the human body. So we use that all the time in ergonomics. But the way in which the work is designed, and you're not putting me in a position that's going to result in me fatiguing and falling, right? If I need to hold something here and I'm leaning outside, the say if I'm going up a ladder, right? And the ladder's like this wide, not this wide, but this wide, and I'm leaning over and holding something heavy. I mean, I could fatigue and fall, right? Because I'm having to apply more force to prevent myself from falling, and then you fall, right? So there's different things of how the work is designed and what I'm expecting people to do that are going to result in issues, right? Chemical exposure, obviously proper ventilation, we know all that kind of stuff, but some of the ergonomics principles could be handling chemicals, right? How do you handle buckets with chemicals in it? What are you asking the person to do that's going to potentially put them in a fatigue position, which then is going to lead to a potential spill, right? And obviously having the appropriate PPE that fits. If we look at things like, sharp tools and equipment, for example, providing, you know, handles that are appropriate for the work that you're doing, right? To try to prevent some of those cuts, right? You're not resulting in fatigue. You're not asking the wrist to be bent as you're doing something, right? You're in a position that you're minimizing some of that. How do you design the work so it's easy to cut away from you, right? Is instead of cut across you or cut towards you, right? If the way in which the work is designed is only allowing me to cut towards me, then is that increasing my risk, right? So do I get a safety blade or do I need chainmail or whatever I need? But, is that the way in which the workstation is designed that's the only way I'm able to do it. If I have the ability to cut across or away from me, maybe that's a better way to design, right? Okay, so just moving on here to make sure we complete everything. So how do we do this to answer that question, fitting the work environment to the worker? Well, just view your work as that system, right? Using that system approach, and I'm going to talk about a little brainstorming activity that I'm sure you're all familiar with, and how to kind of take that little bit of a different systems approach for that. We certainly want to consider and design for all relevant characteristics of workers, right? We certainly need the participation of all stakeholders, obviously, like we talked about earlier with that kind of spaghetti map of work. We need to be we need to understand the requirements of all those stakeholders in that spaghetti diagram of work all have a job to do. So we need to understand what their requirements are and how we can integrate safety and ergonomics into those requirements. I'll send you another tool. It's called a human factors integration tool. I can send you that as well, just the paper on that if you're interested in how to integrate these concepts into different stakeholders, right? Into procurement and production and quality and finance and HR and all the different workplace functions that are out there of how to measure that, right? How to do it is a different story, but certainly how to measure it, I can provide you that information as well. And as some of you mentioned in the chat, training, continuous monitoring, feedback, refinement, all that kind of stuff is important. And those industries that we mentioned before, the aerospace and airlines, there's always continuous feedback in there, even when things go well, right? So learning about when things go well, what did you do that went well that avoided a particular situation or nothing happened, right? Those types of learned behaviors over time can certainly help to contribute to safe events in some cases. So this PMIP example has been out there for a while. People, equipment, materials, environment, and process. It's a way of brainstorming different factors that may lead to a hazard or a problem, right? And there's lots of people factors. I know in ergonomics we encourage a lot of different people factors: not following policies and procedures, not lifting properly, people too short, people too tall, like there's not strong enough. There's lots of different people factors that we obviously have less control over, but these are all factors that could potentially lead to the hazard and the problem, which allows us to come up with recommendations, obviously based on those different types of factors, right? But instead of doing it this way, we encourage looking at it from this perspective, more of a human-centric perspective based on that system design, right? So what that means is, again, it doesn't eliminate those other people factors that we talked about when it comes to not following policies and procedures and height and all those types of things are still relevant factors. But what about the equipment is affecting my ability as a person to do that work? What about the process is affecting my ability? The environment or the materials, right? All of those things are impacting my ability to do the work. So we want to take this brainstorming approach to help with in that context, right? So again, not just the things that I'm doing as the person, but how the equipment is impacting my ability to do that work, right? How it's designed, how it's laid out, that potentially are leading to the hazard. So taking a little bit more of a people-centered approach, and maybe it's equipment that is designed fine, but again, maybe it's the person, as I mentioned before, not following the policies and procedures, right? Or or the system is allowing me to circumvent things, right? That allow me to do things unsafely. Um, so again, looking at it from this perspective to try to brainstorm how all of those things are may be impacting my ability as the person to be able to do that work and perform that work safely. Okay. So a quick kind of reorganization of what really PMIP looks like, of taking that more human-centered approach to identifying hazards and really what those hazards are. So of course, in this section of the presentation, I had a whole bunch of things about taking a systems approach and really what that means. But ultimately, you do that already to a degree, right? Your Plan, Do, Check, Act really is a system approach, right? Because you're following process and making sure that you're making improvements as you go through this process, right? So it is a systems approach model that you're potentially using. But kind of the caveats to this is that the human needs should guide those types of decisions, right? Like, what do I need to in order to do my work, and how might that change a little bit based on the fact that um, we want to make sure that safety is paramount in those decisions, right? We obviously look at those physical needs, those physiological needs, cognitive, social needs, those types of things too, to help with that. And you think, and I feel like I had a slide in here. Well, like, what is, like, as a safety professional, like, is that really my job to ensure that all this kind of stuff is in place? We're talking about like how the work is designed. Like, there's a ton of other stakeholders in our organization that that set out the work, right? This is how the work is to be done. But ensuring that organizations take that human-centered approach helps to eliminate some of those factors that could lead to adverse safety conditions, right? That then you have to go to leadership again and say, hey, can I have some money to do X, Y, and Z, right? And we know it's a lot more difficult to do that, post change, right? So of course we want to be involved in the design stage, and we want to incorporate all that kind of stuff as best we can, right? What's our best practices? What types of things can we implement that we haven't thought about that would help reduce some of that risk? And we don't always get the chance to do that. So, but that's kind of part of this Plan, Do, Check, Act, is all of those stakeholders are involved in this as well. So it's creating those conditions for safety, right? And that's really what we're trying to do as safety professionals, right? We're trying to create the conditions for safety. So instead of the conditions being conditions, and then we're trying to change those conditions to incorporate safety, the systems approach, and incorporating things like Plan, Do, Check, Act. The idea is to try to create those conditions for safety, right, based on how things are designed. And a lot of times you see that, right? You see that learned over time. If you have a new building, hopefully all the lessons learned from previous buildings are incorporated into those buildings, right? um, which happens, but we still need to do those types of things to understand the impact that the human's going to have on the success of the operation of that particular building, right? And that's often the biggest cost for customers, right? Or for businesses, right? Is you have all the capital investment in your building, but you have people there, right? So you have salaries and WSAB claims and all that kind of stuff. So understanding how to utilize them and designing for those relevant characteristics to improve performance will only help reduce injury and obviously increase the bottom line. So um, certainly designing for relevant, just a couple keys before we wrap up, but designing for relevant characteristics such as certain demographics, obviously provide workers with appropriate tools, trainings, and controls to perform work. You have one customer that has a tool that they need to reach out, far in front. I know that kind of looks weird on the camera, but have to reach out far in front to screw in these bolts, right? Well, may not be that appropriate, for the wrist, right, and for the shoulder. So how can we design a workstation that's more appropriate based on, so I'm able to perform that work safely, right? And again, just some of the resources that'll provide you post this, those safety 2, safety 3 types of documents, and all the other types of research that are going out there on this particular topic is looking at the influence of that work system, reviewing that, and seeing, and engaging employees, which I'm sure you do already, to maximize worker and work system safety and sustainability. So in designing for those characteristics, it almost eliminates some of those barriers to try to get people to perform that work safely, right? And of course, this is not anything new. About improving safety should involve employers, workers, and their representatives, external advisors, internal specialists like yourselves, committees, procurement, whatever stakeholders. I'll send you that HFIT tool, that human factors integration tool, that even has a list of what all those stakeholders would be, and the impact that ergonomics and human factors can have on reducing not just MSDs but safety accidents as well. That being said, with all of those stakeholders, we have one last poll here before we wrap up. But which stakeholders other than safety would benefit from including ergonomics, not just for MSD prevention, but just safety in general? Hmm. Yeah, employees for sure. Yeah, employer. Let's give it a few more seconds here. I know we're dangerously close to lunch here, so production, yeah, medical system for sure. Yep, that's good. We can close the poll here just to move on. So that's good. Yeah. So production, yeah, customers, we got a bunch of different examples here. Yeah, perfect. So yeah, definitely the employees for sure. Giving them the tools to operate safely within that system is important, right? So obviously protecting the hazards that exist out there is obviously what we need to do. But what types of tools can we provide the employee to ensure that we're doing that? And how we do that is looking at incorporating ergonomics in a lot of those things. So we look back at some of those hazards that we talked about, or how ergonomics can contribute to struck-bys with the lack of visibility, for example, or falls from heights or ladders because I'm asking my body to apply more force and it fatigues really quickly, and that's what leads to a fall. Um, even in the absence of an MSD in both those situations, and really understanding what the human strengths and limitations are. Um, Review how the work is done. And I know that you do that as well in some of your investigations, and how that work is done to see where those points are that can incorporate some of this stuff in ergonomics. And like I said, we look at that through the lens of MSD prevention a lot of times, but looking at it from the lens of performance, right? Can I decant that in a way that is going to limit spills because I'm not bent over at the waist, right? Um, so how that work is done and how I am interacting with that work, and how that may potentially lead to those safety issues that it's not a back injury from a lift, right? It's more of a fatigue or an awkward posture, or um, whatever the variable is that resulted in that spill or that fall, right? So kind of looking at it from that perspective is kind of some advice that I would provide. Give to you, certainly involving stakeholders, as I talked about, and really focus on top to bottom and inside out, right? So looking at that whole process, right, top to bottom, how that works, what's going to happen after, what happens before that process, and all of those types of things. Because you may have some things in the workstation. Okay, the workstation is designed a certain way, but if the process before that is then introducing a hazard, and then it's gone once it leaves that person's workstation, then it's kind of introducing those types of things, right? If I'm depalletizing if I have a wrap skid, for example, comes off a truck, I have a wrap skid, is that, with the wrapping on, it's sitting there on the floor, there's no hazards, right? But as the human, as I start unwrapping that skid, hazards start to present themselves, right? So maybe I'm lifting up here, or maybe I'm lifting in the power zone, which is great. But as I'm lifting further down, now I'm starting to bend over. Well, now the hazard is starting to occur, right, where it wasn't there before, based on how the work is designed, right? And of course, now I got all the shrink wrap everywhere, so now I'm tripping where it didn't exist before because the shrink wrap is intact, right? So how the things are working, that hazards can just come and go based on the work, right? So kind of looking at all of that type of stuff to try to account for those types of things is important. Okay. A couple things to consider. You can consider something like design thinking. This came from Stanford Executive Design School, and it's really talks about, at its core, it's really a human-centered approach emphasized on the human perspective, and it revolves around the concept of empathy, right, for the different people involved within a given system. So really, what that means is you can Google this, or Google a similar model called the double diamond, but this is a good way of when you're implementing controls, for example, right, is to kind of go through a process like this to ensure that it meets the human need, right, in the work need, right? Yes, there are hazards that need to be fixed, but how do we go through a process like this to ensure that those are accounted for, right? Those different stakeholder needs and different needs of the human. So this is a way to do that as well. So you can either look this up at at Stanford, or you can look up the approach double diamond as well. It's a similar type of approach. Okay. The reason why I threw this up here, and I'll make sure that it's in the post email, Safety Connection post email. These are a list of a ton of standards that exist that look at things like design for ergonomics. So you have ergonomics, and I realize that we all don't have access to all these standards, but the reason why it's up here is that there's lots of design standards for human factors and ergonomics to influence how work is being done. And a lot of these things would have an impact on safety, right? There's ISO 6385 that talks about the design of work systems, right? So a lot of these types of standards exist to help companies design work in a way that limits not just MSD issues, but also safety issues as well. Okay, but I'll make sure that I include those as well. Some other resources that may be a little bit more accessible. MSDprevention.com really focuses on MSDs and not really design, but there's lots of universal design standards out there that can be appropriate. Building codes, and there's lots of EU standards and those types of things that you can utilize as well. You can obviously connect with us as well if you need issues, or you need access to different resources and all that kind of stuff. We'll certainly try to find those for you. But feel free to connect with me anytime about this topic. I mean, the biggest thing with this topic is hopefully there are some caveats here, or some things I provided with you with some of those safety topics to incorporate ergonomics into, which is one thing, but it's another thing to actually do it in reality, right? So I'd love to hear, success stories, challenges, those types of things to try to see where this goes, right? How can we incorporate kind of the systems thinking design concept to eliminate safety differently by implementing ergonomics. So I'd love to hear from you for that moving forward, which would be great. So I'll make sure all the links are provided to you afterwards. We only have a minute. We don't have time for questions. I apologize, but again, I appreciate you attending. I know it's a little bit of a different kind of concept here, but again, I'd love to hear from you. Challenges, successes, those types of things that we can share with everybody to try to incorporate more ergonomics in design to affect safety and not just MSD prevention. So contact information is on the screen. feel free to reach out. But again, I appreciate everybody's attention, and I'm sure we'll talk down the road.